Hi, welcome back on the AI Journey, the webinar series where we can talk about artificial intelligence, machine learning, and deep learning. Today, Gianni Rosa Gallina and I will talk about MLOps and with Kubeflow with two experts. Let me introduce Gabriele Santomaggio and Alessandro Festa. Hi, guys.
Hello.
Hi there.
Hello.
Before continuing, please introduce yourself.
Go, Alessandro.
Okay, I will
Go
start
ahead.
that. So, Alessandro,
Don't be
Alex.
shy.
Alex.
Am I shy? No. Alessandro Festa. Alex, if you want. I'm a senior product manager at SUSE, responsible for everything, every AI initiative here. Back to you, Gabriele.
I'm Gabriele, and I am senior developer at SUSE, and I basically do what Alessandro says. That's it.
Well,
Hi everyone, I'm Gianni, colleague of Clemente in Innovation Lab at Delta 3.
So, why we wanted to talk about MLOps? What is MLOps?
I can pick up that. Let me start. If you want, I can start a little presentation about that, so we can actually go through
Should
that
be
and
great.
explain
Thank
a
you.
little bit.
Thank you.
Sure. No problems. Okay, so let me share this. Okay, so first of all, what is MLOps? Me and Gabriele thought that in order to explain what is MLOps and give you an insight, a little journey about what it means to be an MLOps, we decided to give you this presentation that we call it pipelines and welders. So why pipelines or why welders? So first of all, who are the welders in this case? Me and Gabriele. And why pipelines? Well, let's start with the simplest joke. And the simplest joke is that there are two types of people, especially when it comes to welders. Those that really knows how to build a pipeline, like Gabriele, and those that, let's say, they put some pipeline together, like me, and the result is what you see here in this slide. So when it comes to MLOps, those are the welders in our story. Those are the people actually that have to execute those pipelines. They have to build the pipeline. They have to help the data scientists to build those pipelines. But exactly like in everything else, build the pipeline could be an easy task. And typically end up, if you don't know what you're doing, you end up making things bigger, really complex, and sometimes really disruptive for your infrastructure. So you need to learn how to do so. You need to learn a couple of things. And the first things is that, and this is what me and Gabriele try to solve here, is about, can we make things simpler for both the local experiments, if you need to experiment with local pipeline, with local AI tools, with local AI platforms, and even when it comes to production, especially when it comes to CI and CD. And this is our goal for this small journey we're trying to do with you. So let's start, if you want, and see how we can solve that. And I will start with that. I'm actually asking to Gabriele and maybe even to Gianni about this, because let's pretend I'm the data scientist. And as a data scientist, I'm probably focused in an ideal iceberg idea where artificial intelligence represents the iceberg. And I said, well, as a data scientist, the part that actually is very interesting for me, that is the part above the water, is in very end the models, is in very end end application, and everything that it has to do with that. I don't care about infrastructure, but then I'm asking to the DevOps here in this talk, is the same for you? Are you interested in the same stuff? And so I said, I'm asking you guys.
So I'd say absolutely no. I don't care what you are doing.
me too. Apart from the joke.
I like to be appreciated as usual.
So yes, the important is that it works. So from my point of view, the important is to put your job inside some CI integration, inside Kubernetes. It's important to distribute the loads across the nodes. It's important to automate everything.
Yep.
So if everything works without touch magic scripts or avoid magic shell scripts, you can continue to do your job, and I I can go running and leave you working, basically. So that's what I'm worried about.
Yeah, and that's I assume is the same for you, Gianni.
Yeah, I can also speak about both roles, because what we are currently doing as Innovation Lab, we sometimes are data scientists, sometimes are Devops, sometimes are ML engineer. And I agree that each people, when they wear the specific hat, they just care about what they trust more, they need more. So data scientists want to write as fast as possible something and test something, an idea, and run a model, train a model, or run an inference. While the DevOps, as Gabriele was saying, wants everything automated. He wants performance. He wants that with a simple line of code, or just a hit and enter key, and everything deploys, everything runs. In the meantime, the ML engineer is between the two, as this wonderful image describe. In between the two roles, there is the iceberg. There is the point that everyone cares about in a specific hat, and then the ML engineer, let's say, stays in between the two. He must know what the data scientist does and also what the DevOps want, because they need to talk to each other.
Yeah, and
so we can say that behind the scenes there are three main actors that sometimes doesn't know what the other actor.
Absolutely, yes. And I would add even another things, that if you are lucky, you got three actors. Because if you're unlucky, let's say if you are not a mature company, probably you just have two of those three actors. You don't have the ML engineers. Because the ML engineers need to be someone that is either between brackets, just a DevOps or just a data scientist. Because what Gianni was saying is really important, that ML engineer is a completely new paradigm, if you want. It's someone that has both knowledge that act as a link between those. And the iceberg idea, the iceberg metaphor, if you want, is exactly that. That is like, we care about the part above the water that is completely different. But there's a sort of imaginary line that link those two icebergs in the middle that need to be covered. And that's actually, again, what we try to solve with what we present today as well. That is like, give tools and give ideas how to solve that. So thank you very much, because I think that describes, to some extent, the MLOps concept, but also describe a pain that exists in the market. If you want to run AI, you need to have someone that acts as ML engineer. And if you don't have him, basically, or her, you will struggle with your journey within AI. So me and Gabriele, we try to summarize what we just said in the use case flow, where we start with the data scientist that writes his own model, is try to solve the use case from his own perspective. And he should end up in a CI environment where everything is automated, leveraging possibly a specific platform in the middle, like Kubeflow. So let's start from the data scientist perspective. Now, starting data scientist perspective means you have to write the code. Basically, you have to do your own job. Do math, is doing create a model that solve the use case, maybe multiple models, and possibly train them in order to execute them, to serve them later. And that's basically your starting point. Okay, but where do I run my training? Where I do deploy? I'm deploying on my laptop, on a local data center, on cloud. What should I do exactly to do so? Do I need any infrastructure? If so, what kind of infrastructure? And is a local tool enough? I think those are questions that, if you're not an infrastructure expert, you pose yourself. You ask yourself, where I'm doing start? What I have to do? Now, typically, what you do is starting from a Jupyter notebook. Now, this slide represents something that we will use later live. This is a public example from the Kubeflow community of a Jupyter notebook. And basically drives you, and I'll show this notebook more in details later, but it shows you how to build the pipeline, how to create your own pipeline, that gather the data, manipulate the data, train the model, and then execute the model later in easy steps. So you start with a Jupyter notebook. It's an interactive environment, and you can start there. And I immediately said, oh, then you can use it with Kubeflow. But you don't know what Kubeflow is. So Kubeflow is a very mature project invented by Google, baked by the most known companies in the world: AWS, Microsoft, IBM, SUSE, Red Hat, Canonical, and many, many others. Kubeflow is an all-in platform. So you got the pipelines engine to run your experiment, to train your experiment. You got the model serving, the inference service there. You got the Jupyters to use them along that. You have also metadata and artifacts and a way to optimize your models with tools like Katib. So he has everything there. But exactly like anything that he has so much maturity is also really complex. So we said, okay, the first step will be Jupyter. And with Jupyter, I can create a pipeline. And these represent the end results. This is a pipeline from Kubeflow perspective. Each box represents the steps. And I will ask in a minute to Gabriele to deep dive into that and explain how it works. So basically, we are in a point where we can say, okay, I got the Jupyter, I got the Kubeflow, and I can start. But then it's back to the original question. How do I install Kubeflow? What I need to install that? How do I can do that? And I'm asking actually Gabriele to share his screen and actually show us how to do that, possibly in an easy way. Back to you, Gabriele.
All right. Yeah. Can you see my screen? Yes.
Yes.
You
Go
can.
ahead.
Let me hide this. So today we'd like to speak about K3i. So K3i is a tool basically to easily install machine learning tools. And when I and Alessandro started to work around the machine learning world, we saw that it's extremely easy, and it's still, it was hard and is still hard to install and deploy machine learning tools. Today we will speak about Kubeflow pipelines, but there is Jupyter notebooks. There are other tools that are extremely hard or a bit hard to deploy. For example, most of the time you need Helm, or you need Parton Customize, or you need shell scripts, and you have to combine everything together. What we would like to do with this tool is to simplify the deployment and for local tests and for continuous integration test.
So Gabriele, sorry if I interrupt you. That means basically I don't really have to learn if I need Helm or if I need Customize or if I need any other things. I just need to learn running K3i, and he will take care of everything else.
Yeah, exactly. So one of the question is, what is the difference between Helm, Customize, and the K3i?
Yeah.
So the answer is that we use it. We put them together, and we also are adding shell script before and after the script, because maybe you need to do some things before or some things after. And you need to create your custom script. What we are doing is to prepare some things ready, and you just with one click, one command, you can deploy different plugins or different groups of the plugins together. Our goal is to provide different plugins. The plugins are open source, and if you want, you can add your own plugin.
Basically, it's like a Lego for AI.
Yeah.
Where
exactly.
basically, okay. Because I think that, well, to explain even further, the idea is exactly to say you don't need to install the entire Kubeflow. You can cherry picking what you like, and you deploy over time. So you can focus on learning if you need, or you can focus on just serving the tools you need. Cool.
Yeah, exactly.
So you don't require to be an expert of Kubeflow that knows all the components.
Yes, exactly. And even from the infrastructure standpoint, I mean, the goal is still, and what I expect Gabriele to show us would be that I don't have to care about install the cluster. I don't have to care about install the tools. I just need to do something magically and then get the results.
Yeah. That's the aim. And I'd like to add that Kubeflow, today we will show Kubeflow pipeline. But Kubeflow is a very big project, and sometimes it is extremely hard to understand what part of the Kubeflow I need. So our aim is to decide for you, because we are spending a lot of time trying to understand the best tools, especially for starting, for CI. What are the best tools? And we are preparing different plugins, for example, for CI, for pipeline, for editor, etc., etc. Because if you see the requirements for Kubeflow, for all the installation of Kubeflow, it requires a lot of CPU and RAM, etc., etc. But maybe you just need a part of it. And we can run, for example, the pipeline just using 4 GB of RAM and 2 cores. If you see the requirements of the Kubeflow, it requires 24 giga and 16 cores, some things like that. As you can understand, it's very there are differences between them. So let me show you some things. Today we are going to use Civo Cloud. We decided to use Civo Cloud because it uses K3S by default, and the K3 is based on K3S, and we are introducing basically different Kubernetes distribution, but we started with K3S. So here we have the public DNS name. Let me show you the command line tools of the K3, excuse me. You have a list of the plugins and a list of groups of plugins. So this is only the command line. We are working on also in a web interface UI to simplify the stuff, but that's it. So in order to install, for example, let me apply. So here, this is a group that combines together Kubeflow pipeline and traffic. Because when you install, if you try to install Kubeflow pipeline, it's hard to understand, okay, I have pipeline running. Now, how can I get the web UI, etc., etc.? With this, yeah.
Sorry, Gabriele, just a question. Where are you taking those groups and those plugins? I mean, those are like pre-built, or I can see them somewhere?
We have a public repository where we have different plugins, core plugins. This is the groups.
So
plugins.
That means basically that I can create my own plugins and my own groups if I want, even on a custom repo, for example.
Yeah, you can use, by default, K3AI uses the GitHub repo, but you can create your own repository and you can use your own URLs.
That's cool.
So let me just execute the commands. So now for timing problem, for timing for the demo, we already installed it because the Kubeflow pipelines, as you can see, requires a lot of resources.
But by the way, just to clarify that for the sake of timing, of course, we already deployed, but in the very end, depending on your bandwidth, you can have everything set up in less than 5 minutes. Basically.
Yeah. It's absolutely fast. And as you can see, we provide the way to binding it with, for example, traffic.
Just to clarify, in 5 minutes, with this, we are able to set up for everything?
Yes, that means basically that in 5 minutes, you got something complex like Kubeflow pipeline up and running with exposed URL in the case of a group. So you just need to have to link to this URL and use it. From that point in advance, if you want to add anything else, it will require even less because it's probably a little smaller. And we will show this during this demo. So basically, if I'm a data scientist at this point, you already solve part of my problem, because it's like, okay, Kubeflow is done. All I have to do is just go there and do and collect the URL. That is what Gabriele is doing right now, literally. There you go. And I can start using it, or at least I can start learning it if I don't know Kubeflow enough.
I can say that these really drastically can cut away a lot of waste time to set up everything. Incredible.
Yeah.
Great.
Yeah, and another things that we'd like to do is to don't rewrite anything. So we are using at the moment the official Kubeflow files. We don't want to reinvent everything. We just want to put together they don't ever spend time to set up and understand how it works. In this way, as you can see, we already have the Civo DNS name here, and by default, it uses the standard HTTP port, and that's it. We have the pipeline ready with, I'm using a very low profile with Civo and just a couple of nodes of Kubernetes, and everything is ready. Yeah. And go ahead, Hassan.
So I'm just switching back in the meantime. I'm just switching back to my slide. So one experiment we made is that, for example, we installed the pipelines on a 2 gigs RAM device with one single CPU, and with 2 single CPU, sorry, and it works. It's low like hell. I'm not recommending doing anything, but if you need to experiment, you have let's say a low computational device, you can basically use this way, K2AI. So back to what Gabriele said, and I think this
Alessandro,
is important.
there is a question by Matteo Savori.
Checking the other questions. Does the provision the cluster on the cloud is using already existing Kubernetes? So both cases. So right now we have 2 versions of K3i. In the, let's say, version 1 of K3i, we provision the cluster locally. In the version 2, we are adding also the provisioning over the cloud. That means providing either K3s or other kind of Kubernetes, even over the cloud. Of course, if you're already in an existing Kubernetes cloud, we will add the capability to leverage that. So, for example, in the case of Civo example from Gabriele, all we have to do is just be sure that we can reach the Kubernetes through the usual kubeconfig, and then K3i will, by inheritance, will use that. But the end goal is actually to deploy also low-profile Kubernetes, for example, using spot instances for CI projects. So this way you leverage the cost constraints, and at the same you can deploy a small cluster that you can use to deploy and leverage. I hope that actually does answer your question, Matteo. Okay, so back to here. So basically, Gabriele, you showed me that now I know how to use Kubeflow. Now I know how to deploy it, and so I'm half of my journey, because now I can at least use that platform to solve my use case flow. But well, since we are close to Christmas, let's say that as a data scientist I have a requirement for Santa, and I said, hey, dear Santa, I'd like to have a way to deploy Kubeflow pipelines, and I just saw it, but I'd like also to be able to deploy my own pipeline there. And here's the problem I have. The problem I have is that if I look at the Kubeflow documentation, it speaks about KFP SDK. What's that about? It seems like really something complex. I don't know. So I'm back to Gabriele again. Hey, can you show me the SDK way of this stuff?
All right. Okay. Oh, can you see my screen? No? All right. So,
yep.
Yes. So the Okay, not you, but you. The KFP is the SDK for the Kubeflow pipeline. So let's start with a basic example. Let's say that you have a standard. This is a standard Kubeflow. No, excuse me, a standard data scientist script. This is a standard iris classification. We don't care too much what yeah.
Well, let's say that's and ask Gianni, because I think that is probably something that an ML engineer knows, because from a data scientist perspective, this is something that to me sounds like I have already to learn too much stuff here. I don't know if you, Gianni, you agree with me here.
Yeah, it depends on the data scientist. If some data scientists already did some production project, let's say, he already had to deal with scripts. Otherwise,
but that's the point. I mean, they already moved out from the pure data scientist up to more sort of data engineer or ML engineer, whatever you call it.
Agree.
Exactly. So this is, as I said, a standard, let's say, this is deep learning more script. And okay, this is ready. Now we have to deploy it inside our Kubeflow pipeline, and we are going to use the KFP. The KFP is the SDK for Kubeflow. This is Kubeflow pipeline. So Kubeflow, the SDK actually is extremely easy. I think that is too much easy, and you can create some mess here. Let's focus on these steps. Let's start with this. So you have container ops. Container ops is a container where you can decide to run different Docker image. So the aim is that you leave your script as it, and you can decide to tune it using different Docker images. You can, for example, create different steps, different executions, and you can try it with, for example, the GPU image, the CPU image, etc., etc. Let me show you the KFP in action here. Let's back to the pipeline. This is what we just saw here. This is the representation, the graphical UI of what we just saw. So the first step is to create disk. Create disk, you create a temporary disk where you put everything you need to run your machine learning training. The interesting part is that you can run parallel tasks here. For example, here we are running 2 different training. And
sorry, Gabriele, sorry to interrupt you, but just to clarify, each box is a definition that you showed before.
Yeah.
So the create disk is on. So each box represents a container, all the parameters within the container, all the code within that container, and even the output that this container will basically show up as a result, right?
Exactly.
Okay,
so you can decide, for example, to execute this training using a specific Docker image. You can decide to use this training to execute this training using a GPU or another kind of the image. This is one interesting part, is the conditional. The conditional, what's the aim for the condition? So it depends. Let me run it. It depends how the behavior of the pipeline, and the pipeline can decide to take different ways. Okay, let's see. Okay, so now we created the disk. We are training these 2 different. We are training the same model in 2 different ways, and the winner is training 3. Okay. Why we decide to do that? Because in this specific moment, the winner is this kind. The winner is the training tree. Now it doesn't matter the details on it. What we'd like to show is that you can use different ways. You are able to decide dynamically the way of your pipeline. Here you have the result of the winner, that is basically a trained model. So, and that's it. We usually see the pipeline, the standard pipelines are a set of steps, 1, 2, 3, 4, 5, 6, etc., etc. Here the pipelines are completely different. As you can see, there are different steps, different containers, different ways, and you can have different results. It depends from different, let's say, the situation of your environment at this moment. So that's it.
So that means, and I'm asking to get back to my original presentation, basically. So that means that now I have a way to create my own CI, right, Gabriele? Because I have all the steps I need to do so.
Yeah.
Now, that's super great because basically solved my use case flow. But at least from my perspective, because I'm pretending to be a data scientist, you know what? You still missing my notebook there. I mean, okay, KFP is great. And but I used the notebook before. Can I link those things together? Now let's see if I understood what you just showed me, and let's see if I can use it. And to do so, let me do this. Okay. Now I just want to stop for a second to show I have a better way to show stuff than Gabriele Santomaggio. That's no, everything that you see, I use it because he teached me this. That's the reality. So my way of doing stuff. Okay, just give a context. As before, I have my own cluster here running. That is basically my version of the using Civo. I deploy a very similar cluster of Gabriele with different namespace and etc. And then basically I have this is linked to my laptop. I can see the status. You see I've got a bunch of stuff, the pipelines. Also I have H2O, that is another plugin we support there. So basically then exactly like Gabriele said before, I can basically list the plugins using groups in my case, and I want to deploy my Jupyter notebook. So let me do this, apply -G and take the Jupyter notebook, and possibly I want a Jupyter notebook exposed over traffic. So I'm just that's all I have to learn. Catering apply -G Jupyter minimal traffic for me. It will take care of everything. On the right, you should see is already there, the Jupyter that is being created for me. Now, while I'm waiting, because I already know the results, let me come back here, copy my URL, open a tab. The port is 8888. Do that. Oh, look, I got the Jupyter notebook up and running on top of my pipelines.
Alessandro, excuse me, can you zoom?
Yes, absolutely, yes. You're absolutely right. So do you remember that at the beginning of our journey, we said, oh, I can use the public example for Kubeflow. Here's the public example for you from Kubeflow. This is exactly the same notebook. I already downloaded it, so I can use it. And basically drive me a simple pipeline to explain me how to work. And I got all my own pipeline as well. And I'm using the public documentation of the pipeline SDK to demonstrate that I'm actually doing everything live. So let me log in here and upload that notebook that I was saying that I saved before. Upload the notebook, click on there, and you will see it's exactly the same notebook. But because K2AI is smart enough, he already took care of the first step. I don't have to install KFP. We took care of that. And in fact, to demonstrate that, I'm going to use the public sample here to say, hey, if KFP is there, then if you run this command, you should be able to see results. And the results should say, hey, yes, KFP is installed for you. You can run it. So the only things that you have to do at this point is just take this URL, that is your K3i cluster URL, go down to these simple steps. Sorry, I'm missing these steps here, where you say, okay, this is the URL, that's it. And then I can literally run all the cells automatically. So let's say that run all. I run everything. You see that actually the mark. And it said, hey, something happened. Let's click on the run details. Hey, it's opening a Kubeflow pipelines, and my pipeline is running. 3 seconds. I deployed Jupyter. I took a pipeline and ran a pipeline. Now I can focus on my stuff, and I can focus on learning this stuff properly, because I don't care about the complexity anymore. I don't care about learning how to install, configure, run all those stuff. And by the way, if I need some other things, I told you before that, for example, we got H2O, and I can use H2O platform there to run it. And that's another stuff. And again, if I want to deploy, for example, Katib, I will not wait for Katib to install, but basically I can say something like K3i list -G again. Is there Katib somewhere there? Oh yes, there's Katib traffic here, so I can use Katib. So K3i, you see that actually the pipeline is there on the right. You can actually see that the pipeline was running. Apply -G. Now, Katib is pretty important because it required me to install PyTorch and TensorFlow operators, and then finally Katib. And I do that, and you will see on the right, I will not wait for completeness, but basically you will see on the right that actually we start to immediately install there everything for me. Oh, here's PyTorch is coming. Then you will see in a second TensorFlow show up. And then after TensorFlow, you will see Katib. And in a moment or so, if you want, I will wait for a little bit more. And then now you will see Katib is taking care of the dependency, is taking care of everything that I need. And now you will see actually that we are going to deploy also the 4 Katib pods that are required for me. So basically it's just that. There you go, even the creation of PVC. And that's it. And if everything will be up and running in a second, you literally see that. I'm just waiting for MySQL to go up and running, and then we'll be able to go there. And once it's there, then I will be able to use everything else. So back to the presentation, in a nutshell, we literally show a journey, and we make the life of ML engineers, data science, and DevOps in a way that actually they can support the pipelines, deploy them, use any AI tool that they need, eventually even the inference servers and so on. And as you can see, we're already supporting a lot of stuff, even including GPUs. We did not mention that. So my side, if I'm a data scientist, if I'm a data engineer, if I'm a machine learning engineer, that means to me that basically I can have an infrastructure ready to go. I can leverage my memory, CPU, GPU constraints because I can keep working on that. I can add, remove any module whenever I want, because exactly as you install, you can remove them easily in a clean way. And I can even reuse them multiple times. So I'm asking, from your perspective, Gianni, Gabriele, do you think that from CI production perspective, does it help as well?
Absolutely. What you already shown is just the tip of the iceberg of what the project can do. I confirmed that the WSL support is there. I tested it on my local machine, and really in 5 minutes it was up and running. And I had the Jupyter notebooks up and running, and all the Kubeflow pipelines working. And related to the CI/CD development, I have a few questions, but we can finish the presentation and then.
Yeah, basically is just that, and I'm basically have the slide like the pointers to if people are interested in the project and where they can start for both. Well, let's say if you want to experiment like us on a cloud provider that is really lightweight and really good, like Sivo, here's the link. But for the K3i project, we are absolutely looking for contributors, for helpers, for feedbacks, for issues as well. So docs K3i in is a starting point for the documentation. The documentation will be updated in the next days with the version 2 that we just released, and also the GitHub references. And in the meantime,
Alessandro,
yeah, go ahead.
what kind of license?
Oh, it's Apache license, so you can basically use it anywhere you go. And just as a double check, Katib is up and running. That means basically that if I come back here, take my public URL, go there, Katib is Katib, and I click there you go. You got Katib up and running, and you can deploy and optimize hyperparameters easily. And that's it, basically, from our side. I don't know if there are any questions, any comments, any feedback.
Yeah, I was having a question related to the CI/CD part, meaning we've seen that notebooks are fine. I can use those to publish and train a model from a notebook. Then, which are the parts, which currently for time, we don't have enough time to discuss, but which are the steps to develop such pipelines with the SDK? What are the steps to move from a notebook to a real production environment?
Yeah, that's a great question. And Gabriele, feel free to jump in.
Do you have some suggestion, best practice to share?
Yes. So the first things is exactly what you pointed out. We show the Jupyter notebooks. Now you can create a pipeline from a Jupyter notebook. That's absolutely right. The problem, at least that's my opinion, the problem I see there is that a Jupyter is great to experiment, to create the design of the pipeline. The problem is when you really have to create the pipeline as a real pipeline outside of the Jupyter. Now, the good point is that along with KFP, you have another tool there that is called a DSL that allow you to package this pipeline in a compliant YAML file that Kubeflow can recognize. And typically, we divide the steps in a pipeline in three major steps. The first step is the way you get the data. That is your first step, because you have to split between if your data comes in as a batch or if it comes in as a live streaming flow of data. And even for the batch, for example, where it comes, if it comes from the same kind of data set, if it comes of data, or if you have to manipulate the data up front, because that part is really important. There are a couple of project out there. KF Data from Pachyderm is an example where they try to abstract the data in a way that you can consume them directly without having to manipulate them on the source. So this way you can create your abstract representation of your data set, and then you can use it that. Now, this part is very important. Why is important? Because the problem with data is that that's the most consuming part on building a pipeline, because it's where you have to understand, first of all, what kind of features within the data you need, how it applies to your models. And that leads you to the second part, that is building the model. Gabriele showed in his pipeline something that is really important. He was not using one single model. He was comparing two models to understand which one fit better his use cases. And again, the pipeline will help you to decide that the training model is a part where you decide which model apply better, and not necessarily will apply always like that. So data, then training. But once you got the training, your pipeline possibly should serve the model to the inference. Now, the one thing important, back to K3I use case, that is why we developed that, is also that those three major steps not necessarily run on the same infrastructure. For example, you can run the data at the source, so based on edge devices and sensors and so on. Then you want to do some analytics there. Then you run the train on the center, on your data center, on your local data center, whether it is cloud or on-prem, that doesn't really matter. This is where you leverage GPUs, you leverage high computational power to run the training, to be faster as possible. Then you move to the inference, and the inference maybe come back to the edge devices. So it could be a completely different architecture. Maybe the training runs on x86 and the edge run on ARM, for example. Now, the beauty of K3I is that we don't care about the architecture. You deploy whatever you like, as long as this can run on that specific architecture, it's exactly the same configuration. So if I say deploy TensorFlow ResNet inference server, I don't care if it's run on ARM, if it's run on x86 or whatever. I simply deploy that configuration. So it's really flexible. Now, those three major steps represent high-level a pipeline. And like you were saying at the beginning, Gianni, was exactly that. A data scientist probably focus on the training part. A data analyst probably focus on the data preparation part. They combine those two steps together to create what fit the use case. The ML engineer takes those two parts and create the pipeline and basically decide how to serve the pipeline properly. And then is where the typical DevOps and developers comes in, because they develop the use case, they develop the application. The Iris application that Gabriele was showing before, in the end, is just an application on a mobile phone that recognizes flowers. So that's the tipping of the iceberg for me. This is what I will see. But the whole other party, that was exactly what we try to show during the talk.
I saw components for a training pipeline, but about an inference pipeline, there is a support.
Yes,
you believe
absolutely.
to add some components?
Yeah. So for example, currently we have a TensorFlow serving. We're adding NVIDIA Triton as an inference server. So we're looking at the Bento ML as well, and adding more and more. To be honest, that's the part where we also look for contribution, because, for example, we are paying attention to KF serving as example. So it's just a matter of adding. We just need time to add more plugins, and anyone can contribute that. And that's, at least to me, one of the major goals of K3I. If we are thinking about a tool that can leverage edge devices or remote devices, etc., the inference part would be really, really something that we want to add to that, because again, it's something where I, as a data scientist, maybe I'm interested in. I just want to deploy it. For example, you can deploy TensorFlow ResNet inference server and use it, so you can learn it, and we will add more MNIST and other models there, so you can basically leverage them.
Really cool and promising. Gianni, I think that with this project we can do a lot of things more quickly.
Yeah, related to the contribution, which skill do a developer need to help?
Everything.
Yeah, you need to like exactly. Well, let me do this if you like. Let me share for a second. Okay, for just a sec. So I give you my part of the story. So me and Gabriele, I'm a product manager. That's, you all know this. And as a product manager, basically, my skills are pretty limited. I mean, not the product manager skills are limited by default. It's just a matter of fact that I'm doing another job. So when we started the version 1, we literally used just Bash as a way. And then Gabriele came up with the idea that, hey, we should improve that. We should support customize Elm, et cetera, et cetera. And so we created the idea of the plugins. And what I'm showing you is simple a plugin. I'm taking H2O. H2O is a platform that I showed before. I built this one. So let me just go. That's all you need to write a plugin. We leverage either a remote EML file, whether it is customized or Elm, or a local, between brackets because it's in the repo, EML file. I'm not writing those. I'm taking those directly from the platform. I'm just saying this is the plugin name, this is the namespace, and then the order of things that I need to install. Even if I look, for example, to the groups, that's all you take. Let's say Kubeflow pipelines. All you have to do is say, give me a name, give me a group name. This is the plugin, the plugins you need there, and then eventually how you bind them. Now, those are just standard manifest. For example, this says, hey, go to the Kubeflow plugins pipeline and take it. Let's move to that. Plugins, Kubeflow pipelines, plugin. And actually this one, if I check this URL, basically, is okay. This is because it's not there. Sorry. If I check this, I'm basically doing this: customize cluster scope and resources. I'm here. I'm just pointing to the platform. So those are all the skills you need. The only real skill, if you want to collaborate with us and do something more, is if you have knowledge of Golang, then you can use for K3i Core. We are adding the UI, so you have some knowledge about front-end developing. That would be really useful for us because we can get help there. And well, if you have any knowledge about Kubernetes and AI tools, how to install them, basically that's all you need. You can go there and add your own plugins, add your own stuff. So it's pretty easy. It's pretty, let's say, perfect for someone that want to start collaborating, contributing on GitHub projects and to learn stuff and do something. I don't know, Gabriel, if you want to add something else.
So, or just proposal, documentation, examples. So you don't need to be an expert. So the Golang, we are using Golang in a very easy way because we don't have any, let's say, complex inside the code. It's just executing stuff. We are working on the web UI. Front-end developers are more than welcome. And yes, I think that writing plugins and suggesting plugins is one of the most important now that we are looking for, basically.
And even if you find any bugs and issues, that's another great way to contribute with us. Like use the tool, test it anywhere, WSL, Linux, Mac, wherever. Let us know if there's any bug, any issue there, and that's a great way to contribute with us.
That's it.
Yeah, great.
I can also say that I asked for a plugin and quickly, in a few days, Gabriele was able to to publish the plugin. So I think that it's a promising project, and I will try to contribute, not only asking a new plugin, but also implement one.
So basically, an idea of a typical pipeline development flow would be we can use K3i project as a local development solution, and then we can move it on other cluster, other deployment, right?
Yeah, if you want even better, one thing that you can do is like you use K3i locally to create your own group of deployment. Like I need this, and that, because those are the infrastructure pieces that I need to create my pipeline. And then I can literally create my own plugin on my custom repo. And then when I need to deploy on the infrastructure, I will just need to reissue K3i there. And that is important because it means that you literally have a tool that you can embed in your CI and say, every time you will redeploy the same configuration, then I can push there the models, train them, use them, destroy the configuration, and restart. So it's a let's say it's good for those that need to experiment locally. It's good for those that need to move it into a more CI approach. And it's good also from a reusability standpoint because you know that everything will be deployed exactly in the same, following the same steps as before. And then anything that you go ahead, sorry.
And what about the security? Meaning that currently we can, if you click deploy a public cluster and access it, are there in place some security that can we already apply, or?
Well, that if you want comes back to Matteo question before. That is, well, either you choose to have the cluster up and running on your side, or we can deploy. Let's say the deployment part is more probably for local or quick experiments where you don't really care about the security per se. While whenever it comes to more production side, we expect you set up a Kubernetes properly with all the security. KFP, for example, support authentication through DEX currently. And then we can leverage that, because in the end, we simply deploy as long as we have the right permission. We deploy the tools there.
So let me add that we don't want to we don't want to replace, for example, OpenShift or Tanzu or whatever, CASP or Rancher, etc. This is not the aim. The aim is to provide a very fast way to test locally and to create CI. So this is why we don't care too much, let's say, about security, because if you are local and or if you are using the ACI, so you are in the same box.
Yeah, but because exactly like you say, Gabriele, that is, we are not to replace any Kubernetes flavor or any Kubernetes solution. We try to simplify the next step, because it's enough complex to set up Kubernetes, whether you're using VMware, SUSE, Rancher, Red Hat, or Microsoft, AWS, Google, etc. I mean, complex in terms of making them secure enough for a production grade scenario, that you don't have to spend time to basically deploy other stuff, especially because we all know that you don't have necessarily one single scenario. You are not pure cloud only or pure on-prem. You probably a mix of them, and your data scientists need an infrastructure up and running in minutes to test a few models. You don't have to spend time learning how to do so.
About hybrid scenarios?
It's as before, exactly as I said. The moment I issue K2I apply, it applies to any Kubernetes that can be reached out, and that's it. So that means in hybrid scenario, if I need to deploy, let's say, a Kubernetes cluster with a Kubeflow pipeline locally or on cloud, as long as I can deploy that. For example, one thing we are adding there is what we call Catering Cloud. So Catering Cloud is the idea of leveraging things like Terraform, Pulumi, and etc. to deploy clusters on the major cloud providers easily. So using AKS, EKS, and so on. So this way, basically, you just run K2I apply. You will simply say on this kind of cloud provider, and we will deploy the cluster for you. Of course, as Gabriele said, this is mainly for experiments. This is mainly for CI. We don't really care for the security at that point. But it's a good way to say, hey, if I'm fully Microsoft based on Azure, I want to use spot instances to deploy quick clusters and platforms for my data scientists. They can do their own stuff, then destroy them. So I can basically manage the TCO there and then move it on. Once we will land on production, then we will deploy the proper cluster in the proper way. And then we will just use the configuration of K2I to deploy the platforms.
Yeah, most likely we will support only K2S and kind. For example, we will exclude Minikube. For locally, exactly. And the aim with the Catering Cloud is to provide everything. We will try to do that. But as before, we want to make it extremely easy. So
yeah, but exactly to the point of Catering Cloud is really targeting the CI scenario. Is targeting the idea of where, for example, you're using spot instances. Is targeting the idea of I want to create quickly an infrastructure, configure it, use it, destroy it. That's it. Locally, for example, the fact that we are targeting kind and K3S is also for another things. Minikube is great. You can, for example, run also OpenShift locally. You can also run many other tools like MiniKF. The problem with those tools is that the overhead becomes more and more greater. Like you need a minimum of 8-12 gigs of RAM just to run stuff. Because they are all in, it's like you install all Kubeflow or nothing. Otherwise, you have to figure out how to do so. K2I is instead, as I said, is a Lego for AI. It's more like, oh, you saw before, I just need Jupyter, I just need Katib. I don't care about anything else, and I can deploy them. Now I need Kubeflow pipeline and remove Katib. That's it. that means that my computer can be way, way, way lower in terms of memory and computational power.
But also the time to deploy the infrastructure is drastically reduced.
Yeah.
Anyway, I love it.
Can I
wanted
add?
to contribute. Alessandro, if you can share again the slide with all the references.
Yes, absolutely.
So I'd like to add a couple of things. We are looking for, this is a very young project, and we are looking for feedbacks and even some feedbacks to say, listen, I don't like it. We really love this kind of feature because it's a way to grow. It's a way to learn some things, and so that's it.
Yep, that's it. Those Gateway AI is the perfect way to start.
So thank you for this project, not only because you are here to talk about this amazing project, but also because you are contributing it to some things that we believe that not could be, is a great resource to develop end-to-end project in a better way. Thank you so much. I am remembering to everyone that they can comment under the stream, and of course Alessandro and Gabriele can answer you after a few days, I think also after a few hours. Anyway, thank you again. See you to the next appointment. Remember that the best way to learn is to share. Thank you.
Thank you. Bye.
Thank you.
Thank you, everyone.
Bye.
Thank you.
Bye.
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 Thank you.